Hello everyone, welcome to the class for Geotechnical Engineering. I am Professor Kakade and we are learning unit number 1, Introduction and Index Properties. So this series of the Geotechnical Engineering lectures was started from last lecture. Okay, we have discussed about the what is the soil, what is the geotech. Okay, so what is the definition of a soil with a different means like agriculturist, like geologist, like civil engineer by IS code, and what was the definition according to the Dr. Tarzani. Dr. Tarzani considered as a father of a soil mechanics, which is geotechnical engineering. Okay, so in the last lecture we started the discussion about what is the actual application of geotechnical engineering in civil engineering. So we have discussed about that the whole situation is whole situation about the civil engineer that the whole structures have transferred the load to the soil. Okay, if someone understand this concept from the mechanics point of view, that the whole structure and the component of the structure, it just carries the load and transfer it, okay, from one to another, and finally the whole load of the structure, it is transferred to the foundation and then subsoil. So the subsoil area is the soil area. Okay, so the soil should be sufficient strong and have sufficient bearing capacity, okay, to stabilize the structure. Okay, so first of all, the foundation design. For the foundation design, what kind of the soil it is available? There are two type of foundations, which is the one is the shallow foundation and other is the deep foundation. Okay, there are too many types of a foundation. From that, there is a two major type, which is shallow and deep foundation. Okay, so in the shallow foundation, it is the foundation where we could provide when there is a hard strata. Okay, near to the ground level, and when the hard strata is not available, soil is like a black Portland soil or bentonite, or having a soil which has a very less bearing capacity, then deep foundation is provided. There are several type of foundation like coffer dam, like well foundation, pile foundation, okay, sheet pile, different type of foundation are there, and that foundation are be used or designed according to the soil type. So first of all, we must find out what is the actual strength of the soil, and on that basis we just follow the classification. Okay, then pavement design. Most of time you have seen that one thing is that the road or pavement is just undulated, or the potholes, like these potholes are just occurred here. So there are, so when we are designing the pavement, we must consider the strength of the subsoil. Okay, we consider it as a subgrade. Okay, so major part of major which we can say the major responsibility or major role play by the pavement is to carry the load of a vehicle, okay, and transfer it to the subgrade. Okay, and then another thing is to provide a plain surface for movement. So these pavement are rested on the ground, and that ground should have their own reaction. When we have to consider that is the ground having a sufficient bearing capacity, or what kind of the reaction it took place on the road, that it is providing, or it is applying a uplift pressure or not, or there is some kind of the leakage, what is the permeability, that kind of things must be understand before designing the pavement. Okay, designing the earthen dam. Okay, earthen dam. Earthen dam is made by using earthen material like boulder, okay, like rock, soil, murum, that kind of the different, using a different soil, we provide a barrier to the stream or create the reservoir. So constructing the earthen dam required a special type of soil at its different components. So that's why we need a knowledge of the soil mechanics or geotechnical engineering to prepare a dam. What kind of the soil which is required, what should be the density, how much should it be compacted, is the soil is concentrated or not, okay, what is the void ratio, and that kind of things which must be known before construction of a earthen dam. Earth retaining structure, okay, retaining wall, parapet wall, okay, or we could say that different structures or cross drainage work which is provided on the hilly area for retaining the earth or the retaining the hill area. Okay, so we required some knowledge of a soil or rock for that, designing of an embankment, okay, for that designing of an underground structure, for tunneling, for underground water sewers, water line, okay. So all of, for all these work we require a knowledge of a geotechnical engineering or soil mechanics. So these vast area required knowledge of a geotechnical engineering. So that survey, we consider it as a survey is the first step of the construction. But we must to say that before the survey, when map, after the map study, okay, when we are considering recognizing the survey, first of all we see that what is the soil condition of that particular land. Okay, when the land having satisfying soil condition, we could able to provide, or we could able to build the structure smoothly. If the soil condition is not in favor of a construction, then we must to provide some solution with respect to the problem. Okay, so I hope you understand what is the actual application of the geotechnical or soil mechanics in the civil engineering field. Beyond this, whenever you join any company, you must to have that knowledge to prepare some data or a report for the construction. Okay, and for the competitive exam, the government exam, the too much questions has been asked on basis of geotechnical engineering. So soil which is made from the rock, okay, or minerals, okay. So these are the first concept you must to understand, that the soil is a component made up from the geological cycle. How the water cycle is there or hydrological cycle is there, same like that geological cycle is also present. This whole earth is producing and producing a new thing by itself and recycling it. Okay, so such that water is the product of that cycle, the soil is the product of this cycle. Okay, so soil is obtained from the geological cycle. What is the geological cycle? That first of all, the rocks are, we consider it as a rock form first. Okay, so first of all, rocks are formed. Afterwards, due to the physical and chemical reaction or weathering reaction, the decomposition of a rock happens and soil it produces a soil. So becoming a so production of a soil from the rock is the very long process, that it does not mean that when rock are exposed to the weather in the year the soil forms. No, it is a million of years process. So the whatever the soil you are feeling or you're seeing, it is the product of long-term reaction. Okay, so first of all, we are considering that the rock formed first, or a rock is the originated material, and from that, due to the weathering action or physical action or chemical action, the soil forms. Okay, then soil transported to the another land, or a residual at the particular situation, then consolidation happen, then metamorphic condition occurs, and due to the some other factors, then due to the consolidation and compaction, the soil again become the rock. Okay, I hope you might understand this. This is a cycle. This is That's why it is called cycle. It starts from the rock and it ends at the rock. So it's saying that it obtained from the geological cycle. Okay, and which goes continuously in the nature. It is continuous process in the nature. Okay, geological cycle consists of erosion, transportation, decomposition, and a feel of a soil, so that it goes by rock are eroded, weathered, or we could say that many things. Then due to the weathering or many actions, soil forms. After soil forms, it transported and upheavals. Upheaval is the process of compaction. One by one, the particles are stayed together. Cohesive force occurs, produced between these particles, and it compacted properly, consolidated properly, and like a rock-like structure form. Okay, this is it never become like parent rock, but it will produce a subcategoric rock with having some same properties. Okay, then so on the basis of this, the whole process is by this process. The rock is classified into two types. One is the on the basis of origin. Okay, like first of all, how the soil forms. Okay, how it erodes, huh? And next is the classification on the basis of transportation. Okay, is it transported or it is stayed at that particular position where the parent rock contained it. Okay, so here on the basis of geological origin, how the geologically this rock, this soil will form. Okay, from the rock. So rock is the parent material. On that basis, we are considering the whole process has been started. Okay, so here you could understand one thing, that this process or the decomposition or erosion of the rock is by two processes. One is the physical process, another is the chemical process. So what is a physical process? Physical process is the process by which actual touching or actual physical factors affect the erosion or decomposition of that rock. Okay, so it means that someone hammered on rock. Okay, or due to the rain. Okay, or if the rainwater goes in the cracks of a rock, and then you after freezing the water, the volume of water increases in the form of ice, and that decomposes the rock. That kind of the physical, or by sun rays. Okay, So that kind of the process happens, and this is known as a physical process. Okay, the bearing action also considered as a physical process. Then chemical action, when the chemical of natural chemicals like acid rain is there, or we could say that any other chemicals or gases in the underground, there are too many gases, or when the rocks are in under what we can say, below the ground level, there is no air, so it admire all the environment under this ground. But when it comes to the atmosphere, the whole atmosphere might not be same as the underground atmosphere, so that rock might try to decompose. Like I will tell you one example like that. In a Konkan area there are red soil. It is a product of a red basalt. So red basalt having a one property, that is whenever it is under the ground, okay, it is not exposed to the atmosphere, until then it is same as the basalt. But when it came to the exposure area, it started decomposing. Okay, so the soil is of that parent red basalt is a red soil. So that's why the Konkan region contain a red soil. Okay, next are when the rock decompose or eroded by physical means or by chemical means, both having a different property. Like if basalt is decomposed or erode by physical forces, the property of a product will be different. If basalt is decomposes by chemical process or soil which originated by chemical decomposition of the basalt, then the properties of this soil is different. Okay. Next is the residual and transportation of soil. Okay, residual and transportation, not it must be residual and transported soil. Okay, so if there is a consider one thing is the this is the rock. Consider this is the huge rock hill. Okay, consider it is as a rock. So due to the air or any other thing, the whole this rock been eroded and soil particles are formed here. So when the soil particle does not change its position for long, okay, and it stayed at that position or near to the parent position, then it is known as a residual soil. Okay, but if there is a wind blowing here, okay, and that soil is transported due to the wind for a long area like here, so it is known as transported soil. Okay, sometimes it's happened like that. There is no parent rock nearby the area of a particular soil, but soil was transported very far away from that parent position. This example is like bentonite soil or black cotton soil. If that soil was formed by the chemical reaction or chemical weathering of the basalt, but it formed everywhere in India where there is a river or any other means. Okay, river transport this kind of the soil. Okay, so these are the major two type of the soil. Okay, this soil is classified on the basis of these two fundamentals. Okay, so in the next lecture we will actually start the portion. Okay, so until now, thank you for watching our videos and keep watching our videos.